This is the first of two videos for Chapter P, Section 4. In this video, we're going to be discussing what is a polynomial and how do we perform basic operations on polynomials. So first thing we want to know before actually answering the question what is a polynomial is we need to know and define what is a monomial. So what you see on the screen is a monomial, a times x raised to the nth power. A is going to be any real number. So it could be 1, 2, 3, 4, square root 3, pi, any of those numbers are okay as a. The x here is our variable. That is our variable. N is going to be what's called the degree of a monomial. Now we need to put some conditions on this degree. In order for this to be a monomial, it needs to be a non-negative integer. What does that mean? Well, that means that we can have 0, 1, 2, 3, 4. Any whole number that is positive or 0 is okay for the degree. Let's look at some examples. Oops, wrong way. Each of these, we want to decide whether the expression is a monomial. If it is a monomial, we want to identify its degree. So the first one, 3 times x to the 4th power. Well, 3 is a real number and 4 is a non-negative integer. So yes, this is a monomial and its degree is 4. Okay. Again, this one pretty clearly is going to be a monomial. 1/2 is again a real number and 6 is a non-negative integer. So yes, degree of 6. How about 3 times x to the minus 4th power? Well, what I've said a couple times already is we need this exponent here to be non-negative. So if we start seeing negative exponents, well, we're going to know that that's not a monomial. So no, not a monomial. How about the number 42? One thing you're probably asking is, well, where's the x? We may think this is not a monomial because there's no variable sitting around. But I can actually write this as 42 times x raised to the 0 power. So there is a variable there, we're just not seeing it because anything raised to the 0 power is 1. So again, this is a monomial and it will be of degree 0. What about the square root of 3 times x to the 932nd power? Well, first question I have is 932 a non-negative integer? Well, 932 is a whole number, so we're good there. But what about square root of 3? The question we need to ask is square root of 3 a real number? It is. So this is also a monomial, and the degree is 932. X, this one should be pretty straightforward. Yes, and degree 1. How about 1/3 times x raised to the 1/3 power? Well, again, we need to ask ourselves, is 1/3 a real number? Yes, it is. So we're good on that count. But is 1/3 in this exponent, is it a non-negative integer? Well, 1/3 is a fraction, which is not an integer. Not an integer. So no, this is not going to be a monomial. Square root of x. Now, we've already learned that we can write square root of x as x raised to the 1/2 power. And what we saw in the previous example, if we have a fraction or not a whole number in the exponent, we know that that is not a monomial. 2 to the x. We may think this is a monomial because it appears similar to what we've seen, but the problem we run into is this x is actually in the exponent. We need the x to be in the base, or if the x is in the exponent, then again, this is not a monomial. 0 is going to be a monomial because we can write that as 0 times x to the 0 power. So yes, a monomial. Now, a problem we run into is we may want to say that 0 has degree 0, but we're actually going to give this an undefined degree. Now, that won't come back to bite us in the butt or anything later, so that's okay. We're just not going to define a degree for the constant 0 monomial. Now that we've defined a monomial, we can answer the question, what is a polynomial? Well, a polynomial is a sum of monomials. And you're going to see this long form of a general polynomial. We have a sub n times x to the n, where this a sub n, this is just a real number. And the n is only to identify that that real number goes with the x that has the nth power. Then to that first monomial, we go ahead and we add on as many other monomials as we want. Okay? One thing to note is that this polynomial is listed in what's called standard order, or standard form. And all standard form means is that you list your polynomial in decreasing order of degree. So your highest degree comes first and your smallest degree comes last. We also want to know what is the degree of a polynomial. The degree of a polynomial is the highest degree of the monomials. So highest degree of monomials. Yeah, we already have that there. So, good. Now let's see some examples. 2x plus 3, instructions first. We want to decide which of the following expressions are polynomials. For the ones that are polynomials, we want to know the degree. So, first example, 2x plus 3 times x to the minus 1 minus 5. Is this a polynomial? So the questions we want to ask ourselves, well, this is a sum of terms, so it's a candidate for a polynomial. But we want to know, is each of these terms a monomial? Well, this one is a monomial. 2 times x is a monomial. Is 3 times x minus 1 a monomial? No, that is not a monomial. So, not a monomial. So this is not a polynomial. Once you encounter something like that, where you have it listed as a sum of terms, and you encounter one term that is not a monomial, it's automatically not a polynomial. So let's go through that same logic for the next example. X squared, monomial? Yes. Minus 8x cubed, is that a monomial? Yes. 15x to the fourth, again, monomial. 91. If we're having trouble seeing this as a monomial, you can remember again that there's an x to the 0 on the end. So yes, a monomial. So yes, this is a polynomial. Now, since this is a polynomial, we need to identify the degree. The degree is the highest degree of the monomials. So this monomial has degree 2, this one has 3, 4, and 0. So of those, we'll pick the highest, and this polynomial has degree 4. Okay, so we're also going to run into expressions that look a little different. Now, this isn't written this is a rational expression, and we notice it's not written as a sum of terms, but can we write it as a sum of terms? We sure can. We can write this as 3x to the fourth plus 8 minus 2x squared. Once we write it like this, we do recognize that each of these terms is a monomial, and that the degree of this polynomial is then 4. Fourth expression, very similar to the last one we looked at, except this 8 doesn't have an x on it. So when we expand this, we end up with 3x to the fifth plus 8 over x minus 2x cubed. 3x to the fifth is a monomial, minus 2x cubed is a monomial, but is 8 over x a monomial? Well, this is the same as 8x to the minus 1, and again we have a negative in the exponent of the variable. So that is not a monomial, making this not a polynomial. Last example for identifying polynomials, 42x to the 42nd power. Is this a polynomial? Well, we know for sure it's a monomial, and we actually know then every monomial is a polynomial. So yes, polynomial, and it is degree 42. That's a 2. Okay, so we can also talk about polynomials of more than one variable. But in order to do that, same thing we ran into when we were talking about just plain polynomials of one variable, we need to define what is a monomial of more than one variable. And I'm just going to give us an example, and you can generalize from there. Here's a monomial of more than one variable. 2x to the fourth, y to the sixth, z. So each x, y, and z, they are variables, a product of variables with a real coefficient. And another thing we need to identify is what is the degree of this monomial of more than one variable. In this case, the degree is going to be the sum of the exponents of all the terms, or each of the variables. So we know the z has a 1 exponent on it, so the degree is going to be 4 plus 6 plus 1 is 11. And same as when we were dealing with polynomials of one variable, polynomials of more than one variable is simply a sum of monomials of more than one variable. An example of this might be x cubed, y to the fourth plus 3x, y, z cubed plus 2, x squared, y squared, z squared. Question we do want to answer about polynomials of more than one variable is also, what is the degree? Well, we can identify the degree of each of these monomials. That has degree 7. Again, we add the exponents. This one has degree 5. This one has degree 6. And what we'll do is we'll just pick off the one that is the highest degree. So 7.